Hi students, in this session we will see about the what is the meaning of strain and what are the different types of strain. In the last session I have explained the what is the stress and what is the classification of stress. First, what is the strain? So whenever we are applying any external forces on the body, automatically there will be a change in the dimension. So here you can see this. This is a tensile load which is applied on the mild steel. Here you can see this. After if you keep on increasing the load, if you keep on increasing the gradually increasing the load, then the deformation is occur at the center. So this deformation we are calling as a strain. Here you can see this. This is the the force. For an example, if the force is some at 10 Newton and the deformation is like this. If it is increased to 20 Newton, then again the deformation is increased, and after some thing the fracture is happened. Okay, so therefore the strain, the understanding of strain is very important. So the strain is nothing but change in dimension divided by the original dimension. So this is a ratio between change in dimension to the original dimension. So what is the uh, strain? Here depending upon the type of loading, this strain will be different. So if you are applying the here you can see this. This is a large strain. Here we are applying the load. The deformation is large. So here the same amount of applied load, the deformation is less. So which means if you are applying the load, the deformation is more, you can tell that the material is not good. So therefore you have to understand the what is the purpose of where we are using the material, what is the purpose of that material. If the deformation is more, you can say that the material is not good. And we will see the types of strain one by one. So here you can see this. This is a longitudinal strain and this is a lateral strain. The types of stresses are commonly classified into linear strain, lateral strain, shear strain and volumetric strain. We will see one by one. So what is the meaning of linear strain? You can see this. Here this is a rod which is subjected to the tensile force. The equal and opposite tensile forces are applied. Then there will be the increase in the length. That increase in length divide by the change in length. So here this is a rod before application of load. This is a rod before application of the load, and once the load is applied, you can see that this is the increase in length. That increase in length we are denoted by the del, and original length we are denoted by L. So therefore this ratio will give the linear strain. And next one is a lateral strain. So whenever if you are stretching the applying the tensile load, the longitudinal dimension will be increased. The automatically you can see this here the longitudinal the direction is increased, and but in lateral dimension is reduced. That is nothing but the lateral strain. Okay, so and if you are taking this, the longitudinal strain and lateral strain will be always perpendicular to each other. And next one is the shear strain. The shear strain, here if you are taking any object, if you are applying the tangential force, then automatically there will be the change in the dimension. This the understanding of the shear strain in the earthquake structure is very important. Since the earthquake load is a lateral force, the lateral force which are applying on the structure, then the automatically the structure will be moved. So there will be the movement of the structure will be there. Therefore the understanding of the shear stress and the shear load is very important in the designing of the building subjected to the seismic load or earthquake load. Next one is a volumetric strain. Here you can see this. This is some cube which is taken for explanation. Here the once the force is applied in the longitudinal dimension, and there will be the increase in the length. Here this is a L, and the force is applied in the direction of L. There automatically there will be increase in the length. but simultaneously the width and depth of that cube will be reduced. So as a whole, if you are taking the volume which is before application of load, it is a V. Whenever if you are applying load, there will be change in volume. So that change in volume, ratio between the change in volume to the original volume will give it the volumetric strain. Okay, so therefore the understanding of the types of strain is also very important in the designing of the RCC and also the steel structures. Thank you for listening this video. Thank you.